Hello guys, welcome back to the channel. So guys, we are going to discuss about time complexity today. So many of you might be aware of time complexity. If you do not know, let me tell you guys, this is one of the most important concepts in data structures and algorithms. And to be very honest, it is not limited to just DSA and problem solving. It is much more than that. But since we are focusing on DSA in this particular course, so we are going to consider time complexity, or we are going to deal with it from DSA perspective. So what is time complexity? Why do we need time complexity, right? The question should be this, correct? Why do we care so much about time complexity, right? So guys, understand it like this. Let's say you have written a code and it takes 2 minutes. So you have written a code which is taking, let's say, 2 minutes, and somebody else has written a code which is taking less than 100 milliseconds for the same use case. For the same use case. Now, if I ask you which one is the more efficient, then of course this is a more efficient code, right? Which is taking even less than 100 milliseconds. And there is another code which is taking 2 minutes. So this is the more efficient code. So that is why you have to understand the importance of time complexity. Well, this is a very basic example, right? This is not enough to understand time complexity in detail. We are going to cover a couple of basic examples in this particular video because we cannot cover time complexity in detail in just a single video, right? We are going to solve a lot of questions on data structures and algorithms, and trust me guys, we would be discussing time complexity for each and every question in detail. All the big companies like Amazon, Google, Uber, Facebook, Goldman Sachs, JP Morgan, big investment banks, they do care about time complexity, guys. They do care about time complexity because they want their software engineers to write optimized code. They want their software developers to write efficient code. And that is why this time complexity is very, very important. Okay, so now without any delay, let's start. So on the screen, you can see the example. So I have taken a variable int n is equals to 1 lakh, which is 10 raised to the power 5. And here it is a for loop, right? Inside this for loop, we have just written a print statement that is just printing the value of I. Now let's try to find out the time complexity of this for loop. Initially, the value of I is 1. Now we will check is 1 is less than equals to 10 raised to the power 5. This condition is true. The flow will go inside this for loop here, and it will execute the system.out.println statement, and it will print 1. Now, after this line, it will go here, it will do I++, and now our I will become 2. Again, the condition would be checked, and 2 is less than equals to 10 raised to the power 5. Condition holds true. And now we will execute the print statement, and 2 would be printed. For 3, the condition will be true, and 3 would be printed. This process will keep going on until I becomes greater than n. So whenever I becomes greater than n, the flow will come out of the for loop. Okay, so how can we calculate the time complexity of this particular for loop? See, first time when I is 1, how much work are we doing inside this for loop? We are just printing a statement, and let us consider that this single statement takes 1 unit of time. How much time? 1 unit of time. So when I is 1, this for loop is taking 1 unit of time. Now when I is 2, this for loop will take again 1 unit of time. For I is equals to 3 also, it will take 1 unit of time because we are just printing I, right? And because we are incrementing I by 1 each time, right? Look here, we are incrementing I by 1 each time. So it will go up to n, nth time. So it would be 1. And this would be our nth iteration, because at n plus 1th iteration, this will come out of this loop because this condition won't be true anymore. So how many times are we doing these operations? We are doing this n times because this for loop is running n times, and we are incrementing I by 1 each time. So this will become n. So now we can say that the worst case time complexity, let me write it down. Worst case time complexity of this particular for loop is O of n, and we call this O as big O. So it is going to take n units of time. How much time? N units. Now this unit can be in milliseconds, second, nanosecond, whatever, but we can say that this will take O of n time. So that is how we can calculate the time complexity of this for loop. Now let us move to the next question. Yes, and let me correct one thing. This is not H here, this is just O. Okay, so big O. Okay, now second example. Again, the value of n is 10 raised to the power 5. Here we have a for loop. We are printing I. Each time we are going inside the for loop. But this time, instead of doing I plus plus, we are doing I plus is equals to 2. Now what does this mean? It means we are doing I is equals to I plus 2. Now we will see whether it is going to impact our time complexity that we have calculated in the previous example. Let's figure that out. So when I equals to 1, because we are starting with I1, we will check whether 1 is less than equals to 10 raised to the power 5. This condition is true. So what we are going to do, we are simply printing 1. Now this time I will not be 2. This time I will become 3 because we are incrementing I by 2. So instead of 2, I would be 3. Is 3 less than equals to 10 raised to the power 5? Now this condition holds true. We will print 3 using this print statement, which is inside for loop. Because whenever the condition is true, the flow will go inside the for loop and it will do all the operations whatever is written inside this for loop. Now if you haven't seen my Java playlist, Java tutorial playlist, then the link is in description. Please watch the videos on for loop so that you have understanding of for loop, at least how does a for loop works. Right, this is prerequisite for this particular video. Okay, so now I would be 3 plus 2, which is 5. Is 5 less than equals to 10 raised to the power 5? Yes, this condition is true. Let's print 5. So this process will keep going on, right? Until I becomes greater than n. Now we have to find out that how many times this for loop is going to run, because this time we are not just doing I plus plus, right? We are not just doing this. We are doing I plus is equals to 2. So see guys, first I would be 1, then I would be 3, then I would be 5, then 7. So this is first iteration. This is second iteration, this is third iteration, this is fourth iteration. When I say iteration, I am basically saying that this is the first time we run this loop, this is the second time we run this loop, this is the third time this loop is run, this is the fourth time, right? And so on and so forth. So let's say at kth time, the value of I becomes n. At kth iteration, okay, at kth iteration, the value of I becomes n. Can we represent this 1 as 2 into 1 minus 1? We can represent this 3 as 2 into 2 minus 1, which is 4 minus 1. We can represent this 5 as 2 into 3 minus 1. Correct? This is 5, 6 minus 1. Similarly, we can represent this kth iteration. Now understand carefully. We are multiplying the iteration number here, 2 into 3. We are multiplying the iteration number, 2 into 2. We are multiplying the iteration number, 2 into 1. So here the iteration number is k. So we will multiply 2 into k minus 1. And now, can't we say that 2 into k minus 1 would be equals to n? We can say that, right? Because when we are doing 2 into 4 minus 1, 2 into 3, let's take this example. So when we are saying 2 into 3 minus 1, this is giving us 5. When we are saying 2 into 2 minus 1, this is giving us 3. When we are saying 2 into 1 minus 1, it is giving us this 1. So when we are multiplying 2 with the iteration number and we are subtracting 1 from it, it is giving us the value of I, right? So at this time, we are considering that, okay, at kth iteration, the value would be n. Whose value? I's value, right? So now we have to calculate the value of k. So k would be n plus 1 upon 2. Got it? So how many times this for loop will run? This will run k times, right? Because we assumed that at kth iteration, guys, see carefully, okay? This is extremely important. We assume that at kth iteration, the value of I will be n. And why we are considering this? Because once I becomes greater than n, the flow will come out of the for loop and it will perform the other operations that are outside for loop, right? So we are considering that at kth iteration, the value of I will be n, because after kth iteration, that is k plus 1th, the value will exceed n. The value will exceed n, right? And at this time, the condition will not hold true. So that is why we are stopping here. And here we can say that, okay, this entire for loop will run n plus 1 by 2 times. And you can simply see this because every time we are incrementing I by 2. So 1, 3, 5. Okay, so now let me take a smaller value of n. Okay, so let's say let me get rid of this. So let's say I have n is equals to 10. Now first I would be 1, then I would be 3, 5, 7, 9. And now I, when I will be 11, it is greater than 10. So the condition is not true anymore. So this will come out of the for loop, right? This will come out of the for loop. So now see, how many times we said this loop is going to run? We said n plus 1 by 2 times. Let's confirm it. What is the value of n? It is 10. Add 1 to it. Divide by 2. What will it give? 11 by 2, which is 5. We will take floor value. So how many times this loop has run? One time, second time, third time, fourth time, and fifth time. This is k, right? So that is how we calculate the time complexity of a for loop, right? So now let us move to one next question. Now guys, this is a bit different question, okay? But we will understand it, and now you will see the magic of time complexity. So now again, we have taken n is equals to 10 raised to the power 5, okay? In this loop, what is happening? See carefully. Initially, I is 1. Condition is true because 1 is less than equals to n, which is 10 raised to the power 5. So it will print 1. It will print 1. Now I becomes, see carefully. Now I becomes I into 2, which means I is equals to 1 into 2. Because right now we have I is equals to 1. So 1 into 2, this is 2. This is less than equals to 10 raised to the power 5. So the flow will go inside the for loop and it will print I. So now it will print 2. Now this time I will be multiplied by 2 because the previous value is 2. So 2 into 2, this is 4. Condition holds true. 4 is less than equals to 10 raised to the power 5. So again, it will go inside this for loop and it will print the value of I, which is 4. Next time I would be 4, which is the previous value, into 2, which is 8. 8 is less than equals to 10 to the power 5. So it will again go inside this for loop and it will print 8. This process will keep going on until I becomes greater than n. So now let us write this 1, then 2, then 4, and then 8, right? And we are assuming that after a certain number of iterations, this value will become n, right? Because after this iteration, this value will exceed n, say something n plus something. Basically, it would be n into 2, right? Because we are multiplying I by 2 every time. And this will exceed n. So at this iteration, understand carefully. So this is first iteration, this is second iteration, this is third iteration, this is fourth iteration. So at this particular iteration, we are assuming that the value of I would be n. Okay, you will understand it, don't worry. So you have understood this, right? So now let us represent this. Let us try to come up with a format. How can we represent this? So we can represent this 1 with 2 raised to the power 0. We can represent this 2 with 2 raised to the power 1. We can represent this 4 with 2 raised to the power 3. We can represent this 8 with 2 raised to the power 3. And sorry, we can represent this 4 with 2 raised to the power 2 and not 2 raised to the power 3. Now let us assume that this is the kth iteration. This is the kth iteration. So 2 raised to the power k. Now see guys, this is the 0th iteration, this is the first iteration, this is the second iteration, this is the third iteration, this is the kth iteration. At third iteration, we had I is equals to 8. At second iteration, we had I is equals to 4. And that is why we are assuming that at kth iteration, the value of I will be n. Because understand, after a particular iteration, the value of I will become greater than n. And we are considering that that particular iteration would be the kth iteration, right? And that is why we are saying that 2 raised to the power k is equals to n, right? Because at kth iteration, we are assuming that I will be n. So now understand this. So we can say 2 raised to the power 1 is equals to 2. We can say 2 raised to the power 2 is equals to 4. We can say 2 raised to the power 3 is equals to 8. Now, can't we say 2 raised to the power k is equals to n? We can say that, right? Because we assumed that at kth iteration, the value of I will be n. So 2 raised to the power, see, this k is the iteration. This k is the iteration, bachcho. Okay? So that is why we are saying 2 raised to the power k is equals to n. Now do one thing. Take the log base 2 on both sides. So this will become something like this. Now this is the property of log. This will be cancelled out and this will become k. And hence k will become log n base 2. Now let me write it like this. So k is equals to log n base 2. Okay. So the time complexity of this for loop is, guys, how many times this for loop is running? This is running k times, right? That is what we discussed. This is the first iteration. This is the second iteration. This is the third iteration. This is the fourth iteration, correct? This is the kth iteration, right? So how many times this is running? This is running k times, right? So what is the time complexity? Log n base 2, because this is running k times. And what is the value of k in terms of n? See, the given input is n. So we have to come up with the time complexity in the value of n. We cannot say that the time complexity is okay. No, we have to say that the time complexity is log n base 2, the value of k, because this loop has run k times. How many times? K times. Got it? Perfect. Now there is one more thing that I intentionally did not tell, but now I will tell this to you. See, this 1, 2, 3 and k. Don't you think that we haven't considered this 0? Basically this 1, because 2 raised to the power 0 is 1. Yes, we have not considered this, because if we would have considered this, then we would have taken k plus 1 instead of k, right? But let's not worry about this. We can say that, okay, this entire thing is k. Basically, this is 1, this is 2, this is, we are basically considering this is the first iteration, this is the second iteration, this is the third iteration, and this is the kth iteration. We are considering like this. So we have skipped basically one iteration, right? So the value of this iteration we know, this is 1. So we can simply say that k would be log n base 2 plus 1. Okay, we can simply say this. We can basically add this iteration that we missed intentionally. So log n base 2 plus 1. Now, but the big O time complexity would be log n base 2 only. This would not be log n base 2 plus 1. Now you must be wondering why we are not adding 1 to the final answer. See guys, so when we talk about big O, worst case time complexity, that is big O, we always assume that n is approaching to infinity. What do we assume? That n is approaching to infinity. And whenever we add a constant value, let's say when we add 1 plus infinity, this 1 doesn't make any sense. This doesn't add any value to this infinity, because we know infinity is, I mean, it's huge, it's infinity in itself, right? So even if you add 1 to it, it is not going to make any difference. If you multiply infinity by 100, this 100 is not going to make any difference, right? If you add 1 lakh with infinity, it is not going to make any sense. So that is why we always ignore constants. We always care about the variables. So n is a variable here, right? Because n can change. Right now I have taken 10 raised to the power 5 elements. Tomorrow I can say that, okay, I have 10 raised to the power 8 elements. I can say 10 raised to the power 3 elements, right? N is dynamic. It is not static. It is a variable. But this plus 1 that we just saw here, this plus 1, this 1 is always 1. This is a constant value. This is never going to change. 10 raised to the power 5 will always be 10 raised to the power 5. 100 will always be 100. Right? But n is a variable. So we always talk about variables whenever we talk about the time complexity, especially big O, the worst case time complexity. What? Worst case. Here you see, worst case time complexity. Okay. Now let us move to the next question. So we have calculated the time complexity for this log n base 2, and let me give you a very amazing tip. If instead of this I into is equals to 2, if it was I into is equals to 3, then the answer would have come O log n base 3. Now this is your homework. Okay, you have to do it. If it was I into is equals to 4, this thing, the time complexity would have become log n base 4. Okay, so this is your homework. You have to solve this. So this is the last example that we have for today. Here again, n is equals to 10 raised to the power 5. Now this is a little different, because in this particular example we have taken two for loops, and this for loop, this one, is inside the outer for loop. So we will be calling this loop as outer for loop, and this one as inner loop. This is the inner loop and this is the outer loop. So outer loop is starting with I is equals to 1. Now see, when I is 1, this inner loop is going to run. And how many times do you see this loop is running? See, if you have seen the previous examples carefully, we have already calculated the time complexity for this inner loop. This is running n times. We are incrementing j by 1 each time, right? And we are just doing an addition of I and j. So for I equals to 1, this entire loop, this inner loop is running how many times, guys? N times, right? So when I is 1, this loop is running n times. When I is 2, this loop is running n times. When I is 3, this inner loop I am talking about, inner loop is running n times. When I is 4, inner loop is running n times, right? When I will be 1, inner loop will run n times. So we know this outer loop is going to run n times, because how did we figure out that? Because I is 1, we have initialized I with 1, we are incrementing I each time by 1. So initially I will be 1, then I will be 2, then I will be 3, then I will be 4, then 5, and at kth iteration I would be n. So here we can simply say that k is equals to n, right? Because kth iteration, they see, at 5th iteration I was 5, at 4th iteration I was 4, at 3rd iteration I was 3. So at kth iteration I will be n, right? So this outer loop is running n times, so total n times. And how much time is this inner loop taking, guys? This is also taking n times, because it is also starting from 1 and j is being incremented by 1 each time, and it is also going till n. So this is also taking n times, so this is n square. So time complexity, we can safely say it is n square. TC, time complexity. How? Because when I is 1, we are running this inner loop n times, right? When I is 1, we are running the inner loop n times. When I is 2, we are running inner loop n times. When I is 3, we are running inner loop n times. So for each and every I, for each I, we are running inner loop n times, right? For each I, we are running inner loop n times. For I is equals to 1, n times. For I is equals to 2, n times. For I is equals to 3, n times. And when I will be n, again n times, correct? So total would be n into n, which is time complexity would be, in bigger notation, n square. And we call this quadratic equations. You remember we used to study in algebra because of this power 2. Perfect. See guys, if you have any doubts, if you have any questions, feel free to write in the comment section. I am going to respond to each and every comment, okay? But I want you to understand this concept in detail, okay? Because this is extremely important. Now it may look similar to you as a previous one, but see, there's a minor difference. In the previous question we had this j running from 1. Look here, this was running from 1, right? But here it is starting from I, right? So let's see what is the change in the time complexity for this example. See guys, for I is equals to 1, this inner loop, again I'm going to say this as the inner loop, okay? And this is the outer loop, and this is the inner loop, okay? Because this is inside this loop, and this is outer loop. See, this loop is starting from here, ending here, and this loop is within these parentheses. So that is why this is inner loop and this is outer loop. So for I is equals to 1, I is basically representing the outer loop, j is representing the inner loop. For this I is equals to 1, how many times is this inner for loop running? See, it is starting from I. So basically this inner loop will start from I is equals to 1 and it will go all the way up to n. When I will be 2, it will start from 2 and it will go all the way up to n. When I will be 3, it will. When I say it will, I am talking about inner loop. So inner loop will start from 3 and it will go up to n. When I would be 4, it will start from 4 and it will go up to n. So see, initially the inner loop ran n times. So let me write n. Second time the inner loop runs n minus 1 times. See, this is n minus 1, right? We are starting from 2, we are going till n. So how many terms are there? N minus 1. See, if I have 1, 2, 3, n. So how many total terms are there? N terms. But if I remove this one, then n minus 1, right? So n minus 1. When I is 3, so we have eliminated the first 2, right? We are starting from 3. So we have eliminated the first 2. So n minus 2. For 4, we have eliminated first 3 and we are starting from 4. So n minus 3. And it will go till, let's say, in the final iteration, I will be n. So when I is n, this j will start from n, and because j is less than equals to n, so it will not go ahead. It will stop here. This would be the last iteration for j as well. J is equals to n. So when I will be n, this inner loop will be running only a single time, right? So this value would be 1, right? Initially, inner loop ran n time, then n minus 1 time, then inner loop ran n minus 2 times, then inner loop ran n minus 3 times, and finally when I is n, this inner loop, since it is starting from I, so basically it will start from n, it will go all the way up to n, right? Look at this condition. And since we are doing j plus plus, so next time this j will become n plus 1 and it will come out of this inner loop, right? I hope guys, I hope you are familiar with for loop. If not, then please watch the video. I have mentioned the link in the description. So for I is equals to n, this inner loop will run only one time. So now this is simple arithmetic progression, right? So just calculate the sum. So how many terms do we have? We have n terms. We are starting from 1. So what is the sum of first n natural numbers? It is n into n plus 1 by 2, right? Like I can represent this like this: 1 plus 2 plus 3 plus n minus 3 plus n minus 2 plus n minus 1 and plus n. I can represent this like this also, right? So the sum of this will be n into n plus 1 by 2. So I can say that this is n square by 2 plus n by 2. I can represent this as this, right? So I can say that the time complexity is of n square plus n upon 2. Now what I said, we do not consider the constants because n is too big. So now it is n square plus n, big O. Now understand, this is infinity raised to the power square. Understand it like this: this is infinity raised to the power square and this is just infinity. So this is very, very huge. This is nothing in front of this n square. This n is nothing in front of n square. I mean, I can say this, right? N square is very, very big than n. So we can neglect this n. So finally, the time complexity would be n square. I mean, this is how we calculate time complexity. Okay. And this is again quadratic. So guys, I hope now time complexity is clear to you, at least for these basic examples. We are going to cover a lot of more examples and we are going to see that how do we calculate time complexity for difficult questions, also for difficult solutions. Let me tell it again to you. This is one of the most important concepts in data structures and algorithms. If you are really serious about the top-notch IT companies, then this is going to be there in each and every round, right? So guys, we are going to meet us in next video. Till then, bye, take care, all the very best. If you really like the content, you really like the tutorials, then please do subscribe the channel, like the videos, share with your colleagues and friends. Thank you so much. We'll see you in the next video. Till then, bye, take care.